Hello everyone, this is Dr. Tawabudde, Associate Professor in Department of Mechanical Engineering from Dev Patel College of Engineering, Akoti, Pune. So, this presentation is under the 4-week International FDP on Environment and Sustainability. Today I will present on the emission associated with the electric vehicle charging. The electric grid on which the vehicle are charged differ on their carbon intensities. Each grid is characterized by an hourly generation profile of an inter-week sessional variation are not captured because of the profile represent at average fuel mix over the courses of the year. So, generally here consider of not only the emission associated with the charging electric vehicle on particular electric grid, but also the emission associated with the non-electric miles driven. This includes the miles that here we consider that three types of vehicle, that is battery electric vehicle, plug-in hybrid electric vehicle and conventional vehicle. So, plug-in hybrid vehicle depends in gasoline mode and those tips that the battery electric vehicle driver are required to make the conventional vehicle. As such, we able to provide the more complete representation of total emission associated with that plug-in hybrid vehicle owner includes. Here including conventional emission able to capture the more important story of the plug-in hybrid vehicle. So, this figure shows the 5 grid profile using the main analysis which present a broad spectrum of low to high carbon intensity grid. Although the example of low carbon grid is composed largely of renewable energy, a grid with nuclear, hydropower or other emission free generation source would yield a similar result. So, here 93 high carbon part we can use the 93%. So, here emission associate the scenario shows that 5 the level of emission associated with each charging scenario is based on the carbon intensity of the electric grid at the specific time of day the vehicle are charged. The emission associated with the burning gasoline, the ratio of electric to gasoline mile driven and the efficiency of the vehicle. So, this right side figure shows the emission associated with the mile driven. The conventional vehicle are assumed to be the 0.48 pound per pound carbon dioxide per mile. In that diagram shows that the calculate emission from the both the battery electric vehicle and plug-in hybrid vehicle scenario. So, here we consider that the level of electric vehicle charging. So, this left side is on low carbon grade. This low carbon grade carbon dioxide intensity spikes during the evening peak hours between the 6 p.m. and midnight. The spikes results in high grade base emission of charging scenario have high load in the evening hour. However, the emission from the electricity miles are low at all charging scenarios because of minimal use of carbon based fuel. On low carbon grade, conventional vehicle miles have a significant high carbon intensity than the electric miles. However, the charging scenario that allow for more miles driven on electricity, and the right side the medium low carbon grade has a relatively steady carbon dioxide intensity throughout the 24 hours period. Because of this, the load shape of the different charging scenarios have the little impact on total emission. The different in the total emission between the scenario in this case the depend more on a ratio between the electric and non-electric miles. Workplace charging result in higher grid emission because it allow for more miles driven on the electricity, but when emission from non-electric miles are considered, the scenario result in fewer total emission than the others. In that next slide shows that here the total emission of battery electric vehicle for three electricity grid with low, medium and the high carbon intensity. Here provide the visualization of result, all grid intensity and all charging scenario of all battery vehicle and plug-in vehicles. That in that particular this in the left side, that is low carbon grid, that we compared the total emission from the battery electric vehicle and plug-in electric vehicle to the current when conventional vehicle is used to take in the same set of tip for a low carbon grid battery electric vehicle and that plug-in hybrid vehicles. Each result is about 1/3 of the total emission of conventional vehicles. These results account the emission from journeys the battery electric vehicle must taken in that conventional vehicles. For a high carbon grade, that battery electric vehicle and that plug-in hybrid vehicle results in significant lower emission than that conventional electric vehicle. In the right side, that so that finally we conclude that emission saving are greater for plug-in hybrid vehicle than the battery hybrid vehicle when that grid carbon dioxide intensity is high. This is easily explained by that relative efficiency of the vehicles. Battery electric vehicle results in more electric miles over that overall than the plug-in hybrid vehicles, but the efficiency of the conventional vehicle that is used by battery electric vehicle when when they are unable to use their electric vehicles, the carbon intensity of battery electric vehicle non-electric miles is 0.48 pound carbon dioxide per mile, while that carbon intensity of that when that carbon intensity of that conventional vehicles is 0.48 pound carbon dioxide per mile, while that carbon intensity of that plug-in hybrid vehicle is around 0.29 pound per 29 pound carbon dioxide per miles. Thank you.